All right, class. So today I'm going to talk about Chapter 8, Confidence Intervals. And we're going to do this in two parts. This first part, we're going to talk about standard deviation known for a confidence interval. And I've written a couple things on the page already. So I'm working with this normal distribution. And then this new concept that we're going to talk about is Formula 8.1. Is this standard error of the mean. And so this standard error of the mean, if you look in your book, it is the population standard deviation, and it is divided by the sample size. So I'm going to work a problem out of your book, and this problem is in Chapter 8, and it's the QVC problem. It says, let's say we want to construct a confidence interval for the average order size of a QVC customer based on the sample mean of $129.20 with a 90% confidence level, and to determine this interval, we need two more pieces of information: the sample size and the population standard deviation. So let's just write this down. So they've told us that the average, the sample mean for purchase is $129.20, right? They went on to tell us that our confidence level is 90, right? So our alpha is going to be 1 minus 0.90. So our alpha is going to be 0.10, right? Our sample size, n is equal to 32. And then they also told us our standard deviation for the population was $40.60. All right, sorry for my scribbly handwriting. Let's try this a little bit better. I'm using an Apple Pencil. So we know for this that now this is our mean, and this is our $129.20, right? Our confidence level is 90%. So that means that with a 90% confidence level, I'm going to change the color of my pen. I'll make it red. So for our 90% confidence level, we know that, let's put it here, in between here and here. This is not drawn to scale, but let's just say this is our 90% confidence level, right? And since we know that our normal distribution is symmetric, we know that this is alpha divided by 2 on this side, and this is alpha divided by 2 on this side. So that would have to be 0.05 over here and point over here, right? That makes sense. So now let's just talk about how we would go about solving one of these problems. It sounds more complicated than it really is. So our level of significance is our non-shaded region, right? And so I'm going to do this in steps. So the first step in solving a problem like this is we're going to find our standard error of the mean. And so step 1. I didn't pick the right pencil. There we go. So step number 1 would be to find the standard error of the mean. And so for this problem, this is going to be equal to the $40.60 divided by the square root of 32. Is it 32 or 36? 32. Right? And then that's going to give us 7.173. That is going to be our standard error of the mean, right? And so we now know that for our confidence level, right, it is going to be our upper level. So this is our upper confidence level. And then on this side, this is our lower confidence level, right? So our upper confidence level is equal to our median plus Z times our standard in our lower confidence level is equal to our mean minus times our standard error of the mean. So in doing this, we now need to find our upper confidence level and our lower confidence level. Well, we have if you look up, we now know that, I'm just going to write it over here. So this is step 2. Right? Step 3, we know that if we were to look up the z-score, right, for 0.05, that is going to give us .645. And then the z-score for the opposite end, negative 0.05, right? That's going to give us a negative 1.645. Does this make sense? And then here we are. If we were to plug this in, we would know that our upper confidence level is equal to x bar plus 1.645 times our 7.173, right? And that would be equal to $141. And then our lower confidence level is equal to x bar minus 1.645 times 7.173, and that will be equal to 117.40. So 90% of the orders will fall between $141 and $117.40. I hope this is helpful. Your turn number 1 is very similar in terms of answering. And then the next video, I'm going to show you how to calculate standard error of the mean when the standard deviation is unknown.